This type brings some unusual situations to it, or it seems unusual to me, where we're combining the cubes and the squares, or the sum of squares, difference of squares, sum of cubes, difference of cubes, and we may even see some grouping in here before we get through. We're going to start off with a to the 6 plus b to the 6. Let's see, there's probably 2 or 3 ways I could go about doing this. But I know I'm trying to do something that might involve cubes or squares. You remember if we take the power of a power, we multiply the powers, right? So what if we rewrote this a to the 6th, b to the 6th as a squared raised to the 3rd power plus b, let me put this in parentheses, b squared raised to the 3rd power. So let's see, a squared cubed would be a to the 6th, and b squared cubed would be b to the 6th. And now, if you think about it, I've got the sum of the cubes, except my a is really a squared and my b is really b squared. So if I just proceed with this as the sum of the cubes, then I could say that a squared plus b squared times, let's see, I better put this in a bracket, a squared squared plus no, minus, that'd be a minus because I'm doing the sum of a cube, minus a squared b squared plus b squared 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 squared. Okay, I think that works. And then let's continue with this and finish it off as a squared plus b squared times, now I can go back to parentheses, a squared squared is a to the 4th minus a squared b squared plus b squared squared is b to the 4th. And shazam, I think that's got it. Wow. Hope I don't have to do a whole lot of these. All right, here we got x to the 5th plus 4x to the 4th plus 4x cubed plus x squared y cubed plus 4x squared y cubed, no, 4xy cubed plus 4y cubed. 6 terms. What if we set this up into 2 groups? Let's get this as a group right here, and let's do this as a group right here. And what can we factor out? So in our first grouping, I got x to the 5th plus 4x to the 4th plus 4x cubed. Let's see if I factor out the x cubed. That would leave me with x squared plus 4x plus 4. Okay. And then plus, let's see, well, if I factor out y cubed out of the second group, so now I'm building a sum of a cube I can see. Let's see if we got a common factor here. X squared. Okay, factor out y cubed out of 4x y cubed. It's going to be plus 4x plus 4. Okay, so I got a common factor here when I factor out the greatest common factor out of each group. The common factor is x squared plus 4x plus 4. You know what that looks like? I'll get to it in a minute. What if we got x cubed then plus y cubed? So I got the sum of a cube. Let's think about x squared plus 4x plus 4. That's just a quadratic, which I think is the same as, before I get into the sum of the cubes, x plus 2 times x plus 2, right? X squared plus 2x plus 2x, there's 4x. 2 times 2 is 4, yeah, okay. So the quadratic x squared plus 4x plus 4, I could actually factor down further to x plus 2 times x plus 2. And that's the same as x plus 2 squared, right? Okay. Now let's deal with the sum of the cube. So that would give me x plus y times x squared minus xy, using the sum of the cube rule, plus y squared, and then finish it off by writing this as x plus 2 squared. Wow. Again, I hope I don't have to do these every day.